Good morning, everyone. My name is Vikas. I'm as an assistant professor in computer science engineering department at AKGEC. The topic on which I'm going to present my presentation is multiplexing techniques. In this, I will be discussing what is multiplexing is there, how the multiplexing works, and what are the various types of multiplexing is there. So, this is my outline of my presentation. Introduction of multiplexing, multiplexing operations are there. Then we have a frequency. These are the types of multiplexing, which is FDM, WDM, and time division multiplexing. That is TDM are there. So, I will be discussing this multiplexing is there. Okay. So, first thing is what is multiplexing is there. Multiplexing is a set of techniques that allows the simultaneous transmissions of the multiple signals across a single signal, that is a single data link is there. So, the definition is method by which multiple analog or digital signals are combined into one signal over the shared medium is there. So, here in this multiplexing, if as we the communications data communications increases, due to that reason traffic also increases. There are two ways through which we can send the informations over the communication media. Either each time we have to create a link between the source and destinations, or we can have a shared medium in which multiples links, multiple users connect to that link, and then send it the informations from sender to the receivers are there. Okay. So, this multiplexing technique, which is low in speeds, are converted into high speed signals are there. And multiplexing set of techniques allow the simultaneous transmission of multiple signals across the single data link layer. Okay, single data links. In this multiplexing, we uses the multiplexer and the demultiplexer methods, which is being help in converting the multiple signal into one, many to one, then transmit the data or the single or the shared data link. Then it is being that data or is being demultiplexed there. After demultiplexing it, that data is being sent it to the that intended users are there. Okay. So, this is an pictorial representations in which we have an n number of input line, means it means there are n number of users, or you can say n number of nodes are there, which are transmitting the data over the single channel, that is one link, and is there. It uses the multiplexer and demultiplexers. Here in this, all the data are being means inputs are being there, and when it uses this multiplexer will convert these signals into a single signals and send it to this link there, that is channel there, where demultiplexers demodulate these signals and give it to the output lines are there. Okay. So, this is the operations in which where we have multiple conversations is being done, where A, B, C, D, E are the 5 users are there, or you can say nodes are there. They are sending the data using this only the single channels are there. If let us suppose if there is no single channel is there, then we have to make sure that we have a connection between node A to node A is there here at other end. Then we also with the B, C, D in there, that it will increases the your hardware cost, and it also increases the maintenance cost is there. So, we uses the single channels here, in which all the A, B, C, D are sending the informations, sending the data, and that data is being transferred using the single channels are there. There are various processes being done. Multiplexing processing is being done here, in which these are the various users are there, which generate the signals using the same frequency bandwidth. Now, when that is being sent it to the multiplexer, this multiplexer uses the modulator, and this modulator add the carrier frequencies with F1, F2, F3 are there. Then they are generated in signals are there. When these signals are combined together, when these signals combined together, they are sent it over the this transmission media, that is a single channel there. So, once that is being sent, now at the demux, what it do? It uses the demodulator in order to demodulate all these signals are there. So, this is on a representations where here your demultiplexer uses the various filters. Now, these filters convert into the same signals which is being generated using the modulator and the carrier frequency. Now, these signals are being sent it to the demodulator. Now, demodulator will separate out these carrier frequency is there. Once these carrier frequencies are being separated out, now it send to the data to the output line, or you can say to the users are there. So, this is a way, or you can say process in which the multiplexing and demultiplexing is being done over the transmission media is there. So, this is an operations how the multiplexing and demultiplexing process happens in the multiplexing techniques are there. So, now comes to the types of multiplexing. As I told you that there are three types of multiplexing we uses. One is your frequency division multiplexing is there, then wavelength division multiplexing and time division multiplexing is there. So, first two are your analog, and third one is your digital multiplexing are there. So, now let us take discuss these one by one, in which we have to see how the data is being transmitted from source to destinations using the single channel or single link, where multiple channels are being multiple users, multiple nodes are sending the data using the single channels are there. So, let us take more first one, that is your frequency division, that is multiplexing is there. This frequency division multiplexing uses the same method where the multiplex and demultiplexing is being used. Here this input lines uses the send it to the mux there, where that mux will convert this frequency using the modulator and added the frequencies there. Now, that frequencies once they are added, they are send it using these channels are there. Okay. So, let's suppose there are three inputs are there. So, they are sending the data using the three channels here. In this examples, we are sending using three inputs, and we have not three outputs are there. So, the issues that we can arises when these channels, channel 1, channel 2, channel 3 can overlap with each other. So, in order to make sure there is no overlapping happens, the guard bit which the small section of the channels frequency these channels separate out these channels, that is guard bit, which is being used for the make sure these channel 1 is not overlapping with the channel 2, or channel 2 is not overlapping with the channel 3 is there, and so on. So that there would be no noise or any distortions are there. So, analog signals used to transmit the signals are there. Generally, it is being used for the broadcasting the radio, televisions, cable televisions, AMPS, cellular phones. System used for the frequency division multiplexing is there. This is one of the oldest multiplexing techniques is there, which involves analog signals, as these are susceptible to noise are there. So, as I told you, there are various applications are there. Common applications are the AM and FM radios are there. They uses the frequency band from 530 to 1700 kilohertz is being used for the radio as an air to transmit the data. So, this radio uses the air as a transmission medium is there. So, all radio station need to share this band is there. Another common use is for the FDM television broadcasting, in which each channel has its own bandwidth of the 6 megahertz are there. Now, next one is that is your wavelength division multiplexing is there. In this, we uses the high data rate capability fiber optics cables are being used. They are basically designed for the high speed of the data transmission of the data is there. So, this we here in this wavelength division WDM, we uses optical fiber data rate is higher than the data of metallic transmissions cable, but uses the fiber optic cables to use as a single line waste the available bandwidths are there. So, here in this in FDM, it is an analog techniques is there that can applied when the bandwidth of the link is greater than the combined bandwidth of singular to be transmitted there. In the FDM, signals generate by each sending devices modulated carrier frequencies are there. These modulated signals can be combined into a single composite signals that the bandwidth accommodate the modulated signals are there. So, here in this WDM multiplexing allowed to combine other several lines into one, just like your the FDM. WDM is conceptually similar as an FDM, except that the multiplexing and the demultiplexing involves optical signals transmitted through the fiber optic channels are there. Okay. Here as the speed at which the data is being transmitted is more as comparatively to the FDM, that is frequency division multiplexing is there. So, idea is same, we are combining the different signals of the different frequency. The difference is frequencies are very high here in this case. This is in a picture representations of the WDM. Here we uses the multiplexer and demultiplexers are there. We have the various frequencies are being generated by the different users are there. So, when they are combined together, they uses the multiplexing and demultiplexing, and once and that's transmitted using the single link, they send it to the receiver end, where receiver end will demultiplex it and send it to the intended users are there. So, here we uses very narrow band of light from different source are combined to make a wider band of light. At the receiver, the signals are separated by the demultiplexer, as I already told you. So, although WDM technology is very complex, so basic idea is very simple. We want to combine the multiple light source into one single light at the multiplexer and do reverse at the demultiplexer there. So, here it uses the concept of the prism is there. If you remember in the physics, we have an experiment in which prism is being used there. That prism, you receive the light source from the different angles. Once the prism receive it, it combined all the light source, and from the other end it's send it to the single light source. So it uses the same method for transmitting the data in the WDMS. So applications of the that is wavelength division multiplexing is SONET network, in which multiple optical fiber lines are used by using the multiplex and the demultiplex are there. The third one is that is your time division multiplexing is there. Here it is a digital process that allow the several connection to share the high bandwidth of the link instead of sharing the portion of the bandwidth in the FDMS. Here in this time division multiplexing, instead of sharing the frequency, we share the time is there. Time in the sense कि we let's suppose multiple users are there, they are sending the data, there is a time slot is being allocated to each node. During that time slot, that user that send it that or transmit the data using the same line is over there. So during that time frame, other will not send the data either. So here in each connection occupies a portion of time in the link. Note here that the same link is used as the FDM. However, the link is shown the sanction is a time rather than the frequency. As I told you, in the FDM we use the frequency, and that frequency is being separated out the guard bit so that there is no overlapping here. But in the TDM we use the time is being allocated for each users are there. So during that transmissions, let's suppose user 1 is sending the data and we have 4 time slots are there. So user 1 can use either of the 1, 2, 3, 4 time slots in order to send the data using the same single data link to transmit the data is there. This is in a pictorial presentations where we have 4 devices are connected to the multiplexer. They uses the this is the data flow is there here, in which the data is being transmitted here, and they uses these time slots are being used there. So during this time slots, it asks look for it whether the 1, 2, 3, 4 are being sending the data is there or not. These users chooses one of the time slots and send the data over that time slots are there. Okay. So they uses once it is being reached here at the Dmax. Now it demodulated using the same method that is I had discussed initially, and send it to the these end users over the receiver end. So but the issue that we have to face in this TDM is if let's suppose one user want to send the data and the third user want to send the data, but 2 and 4 are idle are there. Okay. In that case, the wastage of that time slot are being there, because here this method, the TDM, it will ask you have to send a data every time in each time slots are there. Let's suppose this is the time frame is being allocated. For this time frame, let's suppose this is 1 second, 1 and 1 other. The 4 seconds for the 1 seconds, either of these one will send the data, then the second will either 2, 3, 4 and so on other. They have, if still they are not ready to send the data, still they have to send the some data over the transmission medium. That is the wastage of the data is there. Wastage of the that is bandwidth in the TDM is there. So there are two methods generally being used in time division multiplexings, which are going to overcome this problem is there. So let's discuss the first problems, how the picture representations the data is being sent. So TDM is a digital multiplex techniques combine several low rate channels into one high rate one. This is the two methods generally being used. The problem that I had discussed is your synchronous TDM, and to overcome it, then we have a statistical TDM. So or you can say asynchronous TDM is there. Okay. So synchronous time division multiplexing is there, and asynchronous time division multiplexing is there, where asynchronous also can be called as a statistical TDM is there. So in synchronous time division multiplexing, each input connects has an allotment in the output even if it is not sending the data. As already discussed, if any node is sitting idle and they are not sending the transmitting the data, still they are forced to transmit the data in the TDM is there. Okay. So in synchronous TDM, each input connection has an allotment in the output even if it is not sending the data is there. So in asynchronous TDM, data flow of each input connection is divided into units, where each input occupies one input time slots are there. So one unit can be one bit, one character, or one block of data, and each unit, each input unit became one output unit and occupy the one output time slot is there. Understood? So here what it's saying, here the time slots are being used for transmitting the data, but the wastage of time bandwidth is there in asynchronous time division multiplexing is there. Why? Because if any node is not sending the data, that node is forced to send some data during that time frame is there. If it is not sending, then they have to send some any data is there. So, so unit can be one bit, can be there, one character or one block of data. So each input unit became one input output unit is there. So they have to occupy one output time slots are there. So duration of the output time slot is n time shorter than the duration of the input time slots are there. If an input time slot is t seconds, the output time slot is t divided by n seconds is there, where n is the number of connection. In other words, a unit in the output connections has a shorter durations and it travel in faster manners are there. Okay. So data is being transmitted in faster manner, but still the bandwidth is unused due to the idle of the certain users, and there is a wastage. They are being forced to transmit the data is there. So this is a picture representations is there, where we have a time slots is being given to A, B and C3 are there. Data is being taken for every line for the t seconds are there. In this time slots A3, B3, C3, either the, can send the frame is there. And in this time slots we have an A2, B2 and C2 has to send the data. In this time slot A1, B1 and C1 has to send the data here. Okay. So here they using this multiplexer as this is they send it in the form of on a frame are there, and each time slots here if you're seeing here and each time slots in one frame, the A1 is also forced to do, if A1 is sending the data, that's okay, but if B is not intended to sending the data, they are still forced to send the data here there. And so each frame in the 3 time slots, and each time slots duration is divided by 3 seconds are there. So in synchronous TDM, a round of the data unit from each input connection is collected into a frame is there. So if we have an n connection or a frame is divided into n time slots, and one slot is allocated for each unit, one of the each input line is there. If the duration of the input unit is t, the duration of each slot is t divided by n, and the duration of each time frame each frame is t is there. So t is the time frame for the time duration for the one frame is there, and t divided by 3 here is the time slot for the particular users are there. So for t divided by 3 is for the A1, t divided by 3 is for the B1, and the so on. So this is enough for the one frame, then another frame, and the another frames are there. The next one is that is statistical time division multiplexing, or asynchronous time division multiplexing is there. In this statistical time multiplexing, what we do here, if one users is not sending the data, they are not asked to transmit the data here. So they can utilize the bandwidth here in this case. As comparatively to the synchronous, the bandwidth is waste due to if any user is not intended to send the data, they are being forced to send the data here in that case. So in the statistical time division multiplexing, slots are dynamically allocated. Okay, so that has to improve the bandwidth efficiency is there in the STDM. Okay. In the statistical multiplexing, the number of slots in each frame is less than the number of input line is there. Okay. In the your synchronous, we have a frame which is equal to number of time slots are there equal to number of the users are there. But here in this case, slot of the frame is less as comparatively to the number of inputs line are there. Reason being, if any user is not sending the data, they are not asked to send the data. Instead of that, they uses the address from which it is being generated and where it has to be sent it to there, that is being added with the each time slots are there. So here the multiplexer checks each input line in round robin fashion and allocated a slots for the input line if the line has a data to send it. Otherwise, it move on to the next user. So it skip the line and check the next line. Okay, so here in this statistical time division multiplexing, it uses the round robin method to allocate the time slots for each input line is there. And if it is not sending, it skip to that user and move to the next user and check whether the next user is sending the data or not. If it is ready to send the data, accept the data and transmit using this line is there, add it to that frame is there. If it is not, then again it move to the next line is there. This is a difference is there. This is a synchronous TDM, this is a statistical TDM is there. Here we have these are the users are there, A, B, C, D, E are there. Here A1 is sending the data here in this time frame, and the line B is sending the two data is there. Line C is not sending any data here. In this frame, D2 and D1, line D is sending the data. Then we have a line E where it is sending the data is here. Okay. So, in the first frame, this we see where we have an E2 sending the data, D2 sending the data, where C is not sending the data. So, this is a blank here. Okay. So, here this is blank. Then B2 sending the data and A is not sending the data. Then it is a blank here. In the next frame, that is a one frame in which we are here A1, B1 and D1 are sending. So, A1, B1 and D1 are sending the data here. But again, the C is not sending the data, and the line E in which in the second frame, it is not sending the data. So, here the data is not there, here data is not there. But still, they are being forced to send some data over that transmission media. That is the wastage of the bandwidth in your synchronous TDM given. Okay. So, in the statistical TDM, what it do? It uses the check from which source the data is being sent is there. So, it added the address. So, here in this we see in the first frame E2, D2 and B2 is there, and in the next frame A1, B1 and D1 are there. So, here for the A1 is there, A1 we have an address for A. Line B address, and the B1 is sending the frame, data is there. Then C is not sending the data, so it will not allocate the time slot for the line C is there. Now, D1 is sending the data, D is sending the data, then D is there. So, it allocate the time slot for the line A, line B and the line D is there. So, in this case, the line C, and here in this frame, line E is not sending the data. So, they are not in STDM or ATDM, asynchronous TDM, they are not allocating the time slots for the C and E. Okay. In the next frame, here again, you see B2, line B is sending the data, line D is sending the data, line E is sending the data. So, B2, D2 and E. So, they allocate the address time slots for the B, D and E is there. And they are not allocating the line or time slots for the line A and line C again. So, here this drastically improves the efficiency as well as the utilization of the bandwidth in the statistical TDM. So, this is a major difference between the slots. There are various differences there. Synchronous TDM and statistical TDMs are there. The first one is we uses the address, just like I will told you if line A is sending the data, the address of the line A is be allocated there. So, address and output slots in the synchronous TDM is total occupied by the data. In statistical TDM, a slot need to carry the data as well as the address of the destination. So, in the synchronous TDM, irrespective any line is sending the data or not, they still occupy the bandwidth. But in the case of statistical TDM, slot which is going to transfer the data, then the address has to be allocated there. Next is slot size is there. So, since the slot size, both the data address in the statistical TDM, the ratio of the data size address size may be reasonable to make transmission efficient. In the statistical TDM, the block of data is usually many bytes, while the address is just a few bytes are there. Another is there is no synchronous bit is there. There is another difference between the synchronous and statistical TDM, that is there, but this time it is at the frame level. the frame over statistical TDM need not to be synchronized. So, we do not need any synchronous bit in the STDM here. Bandwidth, as statistical TDM utilize more bandwidth efficiently as comparatively to the synchronous are there. So, the capacity of the link is normally less than the sum of the capacity of the each channels are there. Thank you.